Deno is a JavaScript, TypeScript runtime that Joe will tell you more about later. It's not super important for this talk, though. I'm a delegate to TC39. You may have heard TC39 was going on at the same time as this conference here in Helsinki. We spent the last 4 days, or 3 days, deliberating how to make JavaScript better, well, hopefully at least. And I think there's another panel later with a bunch of TC39 folks that are going to be talking about how we standardize JavaScript. I also will do a lot of work on WHATWG and W3C specs, like the fetch spec or the URL spec. And I'm a chair of WinterCG, which is a community group at the W3C that works on making APIs or making sure that web APIs work well between different server-side runtimes. So making sure that you can use fetch in Node and in Deno and in Cloudflare Workers, and it works the same way as in browsers. But yeah, today I'm going to be talking about JSR, which is a new JavaScript registry. I'll tell you more about that in a minute. But let's talk a little bit about the background. So if I asked any of you today, how do you publish a JavaScript package? Probably everyone, most of you would answer NPM, right? You write some code, you set up a package JSON, and you publish it to NPM. But it's actually not that easy to do this in 2024. You are probably writing TypeScript, so you have to first take your TypeScript code, compile it to JavaScript and declaration files. You have to then set up your package JSON with different export conditions for CommonJS and ESM and the TypeScript declarations. Probably if you're doing this, you won't have go-to-definition that works for your consumers because TypeScript has like 3 other options you need to set up to make that work, and they all like are challenged to set up. As a consumer of NPM packages, you often have to deal with like big packages because NPM is not very smart about the way it downloads code. It just like downloads a tarball and stores it on your disk, and maybe half of that tarball is just tests and README files, but it doesn't matter. They're still on your disk. It's gonna use up that space. And then finally, like NPM, even though some people may tell you otherwise, it's Node's package manager, NPM, Node package manager. And that means that it makes a lot of assumptions about Node, like that you are running in Node with Node's resolution, and you have a package JSON, and you have a Node modules folder. And this doesn't really even work well in the browser. So for browsers, we have all these very complicated build tools that that emit some code that can then run in the browser, because NPM packages can't run directly in the browser. So really, I don't want to deal with any of this. I want to just be able to publish my code without having to do all of this stuff. But why is it even like this, right? Why is it so bad? It's not this bad when you're making a website, or when you're like downloading a code editor, or when you're, I don't know, even publishing a package in the Rust ecosystem. Why is it so bad here? Because the NPM registry is sort of done innovating. NPM is owned by GitHub, which is owned by Microsoft, and it seems that they're not interested in really improving the NPM registry. And this is really unfortunate because NPM sits in between everybody that wants to consume JavaScript packages and everybody that wants to publish JavaScript packages, which is like literally all JavaScript developers, right? So everybody that wants to use JavaScript in some way has to go through this bottleneck that GitHub and Microsoft have decided are done, right? And they're done in not a very great way. And you can see this on like the NPM website. The NPM website is the exact same it's been 5 years ago. The last 2 things they added were this tiny little TypeScript icon in the top left there, which tells you whether there's types for your package, and this code tab, which has been in beta for 3 years and still does not put the file that you're on in the URL bar, so you can't share it with anyone else. Why? And this is really strange because like the entire ecosystem around NPM has been evolving. Package managers popped up left, right, and center. Yarn, PNPM, Yarn really pushed NPM to fix their speed of installation, showed that it's possible to install much faster. PNPM showed that using some very smart deduplication, you can save a lot of bytes on disk by sharing node modules folders between projects. And NPM started adopting these things in the CLI, but they never had competition on the registry itself, so they never improved there. And this is particularly concerning because JavaScript is a very, very dynamic ecosystem. Like, you may know this joke. There's a new JavaScript framework every week. And it's true. Like, we publish libraries all the time. And this is like the JavaScript ecosystem is known for this innovation. And yet, the NPM registry is just stuck. It's not keeping up. So how do we fix this? We somehow have to innovate the registry, and we can't innovate NPM itself because, again, NPM's stuck. Nobody wants to touch NPM. NPM is not open source. We can't do it ourselves, right? GitHub has to do this, and GitHub doesn't want to do it. So we have to do something other than NPM. And the way to innovate is to sort of radically simplify the user experience. And the way you do this is, first, you have to figure out what you're even trying to simplify. So let's think about like the two different groups of people that care about a JavaScript registry. The people that are consuming code from it, so the ones that are building applications and websites, that are downloading libraries, and then the people that are publishing code to the registry. And they care about slightly different things, but it's a shared, they have this shared overall vision of things should be relatively simple. But like consumers, they really care about having an easy way to find packages that are high quality, whatever that means. They want to have good documentation for their packages. They want to make sure that when they find a package, it'll just work in their editor. They get type completions. They want to make sure it installs easily in their runtime, and that it also works well with their runtime. They probably care about supply chain security in some way, right? They don't want their package to just install some random stuff onto their system. And they want to be able to audit whether the package was actually published by the person that said published that package. They care about good debuggability. They don't want to be debugging through like minified JavaScript files, but rather through preferably the original TypeScript source code. And NPM really isn't very good at most of those things right now, unless a publisher puts in a lot of care. And that's unfortunate because publishers want to minimize the amount of effort, right? They want to just write some code. They don't really want to spend the majority of their day trying to configure the tsconfig file, your package JSON, and like all the tools you need to sort of set up your package in such a way that it does all these things that consumers care about. Publishers want something simple. They want something that reduces boilerplate. They want wide compatibility for consumers without having to like figure out what that means, right? They don't want to care about like CJS versus ESM. They just want to write some code and publish it. So let's talk about JSR. JSR is our solution to this. It's an open source, completely open source JavaScript registry that was sort of incubated at Deno, and we have launched to the JavaScript ecosystem, and can be used sort of like a drop-in replacement for NPM. So let's talk a little bit about how to fix these individual points here. Firstly, we already have a tool that can make consuming packages really nice, right? Like we have TypeScript. TypeScript, when you write your code in TypeScript, will give you types. And types are great because types can allow you to generate documentation, like using TypeDoc or something like that. But they also give you really great editor completion. So when you import a library, you can just like search through that library by just trying things out in your editor, and then the auto-completions will tell you whether that'll work or not, which is really, really nice. But yeah, there's a problem with this, namely that everybody has to transpile TypeScript right now, because that's what you do on NPM, right? You can't publish TypeScript directly. You publish JavaScript files and d.ts files, which means when you're publishing, you first have to transpile all your TypeScript. This adds a couple of problems, like it makes it very hard to audit your code because there's this opaque step somewhere that takes all of your source code and then mangles it in some way and outputs some new code, which sort of breaks the like supply chain security, like trust chain that you want. And it also adds significant complexity for publishers. Like if you've ever talked to anybody that publishes a large TypeScript project, they're going to have some horror stories about like how they had to use project references and declaration maps and all these crazy things to get their TypeScript to emit correctly. So what's the solution to this? Your registry just understands TypeScript. You just publish TypeScript to it, and the registry deals with it. There's a bit of a caveat here, though, which is Node, the most widely used JavaScript runtime outside of browsers, doesn't support TypeScript. So you can't just like upload TypeScript and then download it for a Node project, because Node won't know what to do with it. So for this, we need to still, at some point, turn that TypeScript into JavaScript. But we can do this in a single centralized location inside the registry, where a trusted transpiler can take the TypeScript code and turn it into JavaScript. And this gives you some nice benefits for supply chain security, but it also means that publishers don't have to deal with this. They just upload TypeScript, and then for users that need JavaScript, JavaScript pops out on the other side, and they don't have to deal with it. So it looks like this. You're writing some TypeScript files. You write a little jsr.json file. This is like your package manifest. It has a name. It has a version. It has some exports. But there's no like import, require, and types in these exports. These are just like very simple name in your import specifier to file mappings. And then it goes into JSR. And then JSR will generate a bunch of things from that. It will have a way for you to import that package in a bunch of different runtime environments, in Node-compatible environments like Cloudflare Workers or Node itself. But you can also import them directly in Deno, and that will give you some other benefits, like Deno understands TypeScript. So when Deno is importing something from JSR, it'll actually not pull down the transpiled JavaScript file, but it'll pull down the TypeScript source code directly, which gives you a bunch of nice benefits during debugging. And then additionally, because you're uploading the original TypeScript source code, we can just take that source code and generate documentation from it. So JSR just generates documentation for literally every package you publish to it. And it's on the website, and you can search through it. I'll show you more about that in a bit. But just creating a new registry isn't really good enough, because most people already use NPM. And if you just create a new registry, and everybody's already using NPM, and it requires them to like republish all of their packages onto that new registry before they could use it, nobody's going to use it. So we don't require you to do that. JSR can just import packages from NPM. You can also use JSR packages from any project that already has NPM set up. So if you're in a project that has a Node modules folder in a package.json, there's a command you can run that will install a package from JSR directly into your Node modules folder using your existing package managers. So like pnpm, yarn, even the npm CLI itself can install packages from JSR. Yeah, and this means that JSR is like very good at catering to different runtimes in their preferred format. So what I mentioned earlier, when Deno pulled something from JSR, it downloads it in TypeScript. When Node pulls something from JSR, it downloads it in JavaScript. JSR is really good at this. You publish some clean TypeScript source code, and then JSR will know what all the different tools will understand and give them a different result that is optimized specifically for that runtime. And JSR also has indicators on the website that a publisher or an author can use to say, hey, this package works really well in Deno, this package works really well in browsers. So a user at a glance can just really easily figure out, hey, I can use this package in my Node project. JSR is also really secure and auditable because of this publishing of TypeScript, plus some other things. One of the really cool things I think that JSR does is every time you publish something from CI, and actually when you're publishing from CI, you don't need to have some authentication token. It just like knows about GitHub Actions, and you can go to the website, link your GitHub repo, and then publish directly from GitHub CI without having to set up any tokens. Every time you publish from CI, it logs something to a public transparency log. And that transparency log says, this user at this time from this repo published this package to JSR. And this is like a cryptographically verifiable way to see that the code that you're using is actually was actually published by the person that you think published it, and not by some malicious third party. JSR can generate documentation from your TypeScript. You just write tsdoc or jsdoc in your source code, and JSR can generate this nice HTML view of all of your functions and your packages directly on the website. And JSR can even link directly to MDN or your runtime's documentation when you have things like a uint8 array or maybe some built-in API from your runtime. Another thing that's really cool, because JSR has so much information and like very raw information about your package, like the amount of documentation you have and the sort of amount of types you have in your code, we can generate a score from these things. And we can like in a very glanceable way tell you this package is very good. It has a lot of documentation. It's probably easy to use because of this. And this makes it really nice for users when they're searching through a bunch of packages to quickly say, hey, these ones may be doing the same thing. This one has a lot more documentation. I'm going to use the one that has more documentation. And there's a lot more, right? Like I mentioned earlier that npm's files tab doesn't let you link to specific files. JSR's files tab does. You can yank individual packages. So if you're publishing something on a Friday evening, and then you get a flood of bug reports that something's broken, you just go to the website on your phone, click on the yank button for that version, and then the problem will be deferred until Monday, right? This is very nice. You can view dependencies, dependents on the website. You can do symbol search. So there's a search box on the website. You can open a package, type a name or something into that, and then you can see whether that package exports that function and see all of the documentation for it. So let's try it out. What time are we at? Perfect. So let's start by figuring out how Chrome works. There we go. OK, so let's go to the JSR website. This is the JSR website, jsr.io. You can see I'm signed in. And the first thing you're greeted with is a giant search box to search for packages. So let's search for std bytes, which is a part of the Deno standard library that helps you manipulate uint8 arrays and similar structures like that. So when I click on a package, the first thing you see, or actually, let's head back to the search. The first thing you see is in the search, you have the runtime indicators here. So you can see that this package works in browsers, it works in Deno, it works in Node, it works in Cloudflare Workers, it works in Bun, and it's a 100 score package, which means that there's documentation, there's good types, it's published in a secure way. Like you can hover over this and see it's built and signed on GitHub Actions. I can click on this transparency log button, and this is very small, but like there's a cryptographic signature in here that tells you that this was actually published from GitHub Actions and like what repo it was published from. You can see all of the symbols that are exported. So there's a concat function. This concat function concatenates multiple uint8 array buffers together. There's some usage examples here. This is like nice documentation, right? I can click on this uint8 array. It takes me to MDN to tell me more about what a uint8 array is if I don't know that. I can go back over here and see the list of all the different exports that this package has. I can see all the different versions. I can see all the dependencies. This package has no dependencies. I can see all the different packages that depend on this package. I can see the score. These are all the different like indicators that go into whether you have a 100% score or not. Yeah, that's like sort of what JSR looks like from a consumer side on the website. I'll show you how to install a package in a bit, but let's go on to writing some code. Let's publish a new package. So I have a editor here with a TypeScript file, and I intentionally haven't written like any tsconfig files or anything like that, just to sort of like go through the entire process with you. So our first step in writing a package is figuring out what we even want to write a package for. And what I'm going to do is I'll write a package that has a function called detect that tells you which runtime you're currently in. So it'll return a string that's either Deno or Node or browser, depending on whether it's running in Deno or Node or in the browser. And it'll actually also return null if it couldn't figure out what runtime it's in. So I can just start writing my code here. You probably all do this 100 times a day. So let's write some types for this function. My detect function can, as I said, either return Deno or Node or browsers, or well, browser or null. And then we add some conditions to check whether we're in a certain environment. So if Deno is in global this, if there's a Deno global, then we're in Deno. If there's a process global, then we're Node. If there's a document global, so the like HTML document in global this, then we're in a browser. And otherwise, we return null. OK, that's our package. It's a very, very complex package, right? So let's start by seeing whether this works in Node. As I said earlier, Node can't run TypeScript files, so I'm going to have to pipe this through TSC or something to check whether it works in Node. So I guess I'll do that, TSC index.ts. And I run this, and it outputted comment.js, right? Bad default, but I guess fine, we'll deal with that. Let's add module. I don't know what the different options are. Module es next. OK, Probably that's ESM. Yes, it is. Great. OK. So now we have JavaScript source code. That's great. Let's try to use that in a Node project. So I have I'll create a new little file here, main.js, import detect from index.js, and console log detect. And then I run that file through Node. What is it? Oh, it wants an ES module. OK, it has an ES module. Well, anyway, I have to create a package JSON file. Yeah, I don't know. I'm not a Node developer. I'm sorry, folks. Here we go. OK, I need to call the function, though. There we go. And we're Node. OK, I hope you can all see that. Oh, no, you can't. There you go. Now you can see it. We're Node. Let's also try it in Deno. So in Deno, I can just open the REPL, import detect from index.ts. Deno can just run TypeScript files. And let's call detect here. And we're in Deno. OK, so our package works. Let's publish it. So if we were to publish it to NPM right now, we've generated JavaScript so far. We would now need to generate some d.ts files. We'd probably have to generate source maps and declaration maps. But remember, we're not publishing to NPM. We're publishing to JSR. So I'm actually going to get rid of all these files and just create a JSR.json file. And what do I put inside this JSR.json file? Well, I go to the website. And I click over here and click publish a package. And then I'll have an interactive flow that walks me right through how to publish a package. I'll select a scope. All packages on JSR are scoped. There's no top-level name squatting on JSR. All packages are inside of an @scope. And I have to give it a name, runtime detector. And I click on create. And now I have a new package on JSR. And I have instructions on how to publish it. So it tells me I have to create a JSR.json file with these contents. Let's do that. So the contents here are the name. This is the name of the package on JSR. The version that I want to publish, currently publishing 0.10. And then the exports. Exports is the files that you want to expose in your package. And I don't have a mod.ts file. I have an index.ts file. So I'll change that. And then I can publish. And I have two options on how to publish. I can either publish from the CLI using like an interactive flow, or I can publish from CI. For now, let's publish from my local terminal, and then maybe if we have time, we can publish from GitHub later. So I copy one of these commands. If you have Deno, you can just run Deno publish. Otherwise, you run npx JSR publish, and press enter. Oh, I have to download something, and here we go. Oh, OK. Then, OK, this is what it did. I ran npx JSR publish, and it sent me over to this website, and this website is asking me to interactively authenticate. So remember, JSR doesn't do authentication tokens that are stored on your system, because that has a lot of security issues that come with it. So instead, every time you publish something, it pops up a browser window where you're logged in with your GitHub account, where you can click on approve. And when you do that, you can see on the website how the publishing is going. Take a couple seconds, and there we go. The package is published. So if you now go to @Luca runtime detector 0.10, you'll see this package. But you can see this is not great so far. We don't have any docs. We have a super low score. But you can already see my detect symbol is here. And we already have some very basic documentation that was generated from the types. So the documentation really gets better as you improve it yourself, right? Like as you write comments on your code, the documentation improves. And you can see this because if I go back to my terminal, or my editor rather, and I add a comment on my code here that says, I don't know, this function detects which runtime you are executing in. Returns the runtime you are in, and null, the runtime could not be detected. Excellent. And then I bump the version, and I run npx JSR publish again. And I click on approve. And wait a second. And I click on the symbol now. I have more docs. I'm sorry, the screen's cut off at the bottom there, but OK, yeah. So you can just gradually improve your docs, and you can see that actually just adding docs for this function took my score from a 29% to 58%. Docs is like the majority of the score. So if you have more than 80% of your package documented, you'll get full marks on docs. If not, if you get less, if you have 10% of your package documented, you'll get like maybe one part of the, or well, I don't know. If you have 1 of 10 symbols documented, you'll get like 1/10 of the score for it. But there's a bunch of other things I can easily do to improve my score. They're all listed out in this list over here. So one of them is the package has a description. Right now, if I search for this package, it won't show up with a description. So I can change that by just going to the settings and saying this package, or well, detect which runtime you are executing in. Save that. Took my score to 64. Great. Runtime compatibility. What browsers? What does this work in? It works in browsers. It works in Deno. Works in Node. And it doesn't work in Cloudflare Workers and Bun because it can't detect those, so I'm going to mark them as not supported. And save changes. And you can see this shows up in the works with up here now, and my JSR score has gone up to 76. What else can I do to improve my score here? So has a README? Yeah, I can add a README. So one of the things that JSR gives you a score for is having a README, but the other one is having an example in your README, because we think it's really important that when you drop on to a package page, you can immediately get some idea of what to do with this package. And an easy way of doing that is usually by having an example that you can look at and see, hey, I can import this thing from this package and use it. So let's do this. Runtime detector. I feel like I'm going to write the same thing over and over again. This package detects what runtime you are in. And I'll add an example for how to use it. So import from Luca runtime detector. And the function was called detect. And let's log that out. And this could print out Deno, for example. And then what I do is I will bump my version again and run npx JSR publish. Click on approve. Give it a couple seconds. And it's published. And now I have a README, and I have 100% score. OK, so published a package. It's on JSR. It has 100% score. But how do I actually use this package? So you can use it in a bunch of different runtimes. We have this nice little drop-down over here that shows you the different runtimes you can use it in. If I'd selected Bun as one of the options in my works with, then it would also show up here. But I didn't. So let's start with how to use it in Deno. I can go back to my symbol, and it'll show me exactly. I can Deno add this package. I have an empty little Deno project over here. There's nothing in it. It's a Deno JSON file and a main.ts file. I run Deno add. And that's added the package. And then I can import that. So this is what the Deno JSON looks like. And then I can import that and run detect. And you can see I have docs, right? It pulled the docs directly from JSR. If I click on this, I'm in my TypeScript code. This is not JavaScript code. This has comments on it. This is my original TypeScript code. And you also see I don't have a node modules folder or anything like that. That's just how Deno works. Deno installs everything into a global cache directory. You don't need to deal with folders local to your project. And I console log this detect function. And if I run Deno run main.ts, Deno can run TypeScript, remember, logs out Deno. Cool, this works in Deno. Let's try Node. So what package manager should I use? What's your favorite package manager? I see a very enthusiastic audience this morning. OK, fine. I will use Yarn, because nobody answered. So this is a Node project, empty package JSON. I just have type module in here to make sure this is an ESM project. And I can just run yarn DLX. Yarn DLX is like npx, but for Yarn, JSR add Luca runtime detector. And this is going to add my JSR package to my package JSON, install it into my node modules folder over here. And you can see in my node modules folder, there is now actually a JS file, because remember, Node requires JS files. There's also my TypeScript source code, though, and you'll see why that's important in a second. So I can do the same thing over here, import my code. I can head back here, copy the symbol, and paste that in there. And then console log detect. And yeah, my types also work here now. And because of the way that JSR transpiles your code, if I click on this detect, it actually also opens the TS file, right? So when you're debugging, because of the way that the source maps work, when you're stepping through things in the Chrome debugger or in the Firefox debugger or anything like that, you will be looking at the original TypeScript source code for these packages. You won't be looking at transpiled or minified JavaScript, which is really nice, really, really nice. So let's see if this works. Node index.js. It does. You can't see it, but it does. It executed in Node. And if I was running in a Vite project, I could just import the same package in a Vite project and try it on a browser. It would work too, but I don't know if I have enough time for that. I have time? OK, then let's try that. So let's go. I will delete all of this stuff in here and run npx. No, what is it? npm create Vite. Yes. And we're going to say this is a vanilla project. We're going to use TypeScript. And hello. Oh, Vite project. OK, so we have a Vite project, brand new Vite project. And I can do the same thing in here. I don't know what package manager this is using. Let's use npm to showcase that works too. npx JSR. Oh. Wrong project. npx JSR add Luca runtime detector, press enter. And this is installing, and you can actually see it's using npm install under the hood. And my node modules folder now has my package inside of it. And if I head into this Vite project, actually let's start it up first. npm dev, npm run dev. Vite's running. Let's see that it's actually running. It is. I head over here, and let's just replace this Vite plus TypeScript with Vite plus detect. OK, great. Vite plus browser. OK, project works in Vite too. Excellent. So yeah, that's publishing to JSR. I didn't have to deal with tsconfig files. I didn't have to deal with any build tools. Things sort of just worked. And I have a really nice page now that has a score, or sorry, that has documentation for my package. Oh, this is the old version. Has the runtime indicators in it, has README, all these things. This is like a nice homepage for my website now that I can share with folks. Yeah, and this also works as if you have a larger package. So the STD packages that I showed you earlier, there's like 40 of them or something. And some of them have like hundreds of symbols they're exporting. And this will scale to that. Like you will see documentation for the 100 symbols. You have search. So if I type detect in here, you can see my detect module shows up in the search. Yeah, that's that. Let's head back to my slides. OK, so I wanted to show you real quick how this documentation generation works, because I think it's kind of interesting. I don't know if this is large enough to see, but this is what your code looks like on the left. These are equivalent, right? So the code on the left generated the documentation on the right. And the way this works is that we interpret the JS doc comments on the left, and we sort of map them to places we put into the HTML on the right-hand side. So if you have some description on your symbol, we will put that in the HTML there. If you have an example, we will render that with a nice title in a code block with a little thing that you can open and close. If you have a lot of examples, this little uint8 array down here that's clickable and links to MDN actually is coming from the TypeScript types. And this little text over here that's describing what the source parameter does is coming from this @param function in my JS doc. So did we succeed in making the experience better? I don't know. That's up to you to judge. But I think I don't know. I think it's quite nice to use. Yeah, I could show publishing from GitHub. Let's see. Oh yeah, I still have 10 minutes. OK, I'll show you real quick how the publishing from GitHub works too, because I think that's kind of cool as well. So let's init a GitHub or a Git project and head over to GitHub, github.com. And create a new project, or new repository, rather. runtime, what did I call this detector? I'll create this in my personal account, create repository. Okay, and then I will git add, git commit. Oh. Actually, can I do this? Yes, I can. I need to plug in my SSH key to publish to GitHub. OK, so I push my package to GitHub. Great. So now if I want to publish from GitHub, I can head back to JSR. And where is that? Over here. Head over to the Publish tab. And say I want to publish from CI. So the repo that I was using is Luca runtime detector. Click on link. And it's now linked to this repo on GitHub. This is the one we just created. And it gives me a GitHub Actions workflow file that I can add. And you can see there's no tokens I have to set up, right? This just works without any tokens. Where's the project? Here we go. So workflows. No, what is it? .github/workflows publish.yml. I paste that in there, and let me increment my version. So I'm going to publish 0.13, and I'll add some docs in here to show this is actually coming from GitHub. Coming from GitHub. And publish from CI. Let me commit that and push that to GitHub. And if we wait a second, GitHub Actions will trigger. And we'll start publishing my package to JSR. So we wait. How are you all doing this morning? Still very quiet. I can imagine. It's like 9 in the morning. I also didn't want to get out of bed. I'm happy you're all here, though. OK, we've published to JSR. Again, didn't have to set up any tokens. I can click on this link and published from GitHub Actions. I have the little checkbox now. So if I go to my score page, you can see I have all of the checkboxes, including the hash provenance, which is the one that you get for publishing in a way that is verifiable for supply chain security. Cool. So yeah, that's publishing from GitHub. Also very easy, in my opinion. Let's head back to the slides. So that's all I had to show about JSR today. We'll have a little bit of a Q&A at the end after Joe's talk. But yeah, if you want to try out JSR, just head to jsr.io. If you want to publish a new package, jsr.io/new. And there's already a bunch of different packages on there that were at some point or another also published NPM, like Hono, the web framework, or Orama, the search engine, Neon, the Postgres database driver, Valabot, the TypeScript I don't know, like input verification library, I guess. LaunchDarkly, a feature flag system. Yeah, you can find all those on JSR already. So thanks everyone for listening, and I'll see you all in a bit.